Hi students, today we are going to discuss purification methods, that is refining. Purification nothing but refining. What is meant by purification or refining? We already extracted crude metal. Crude metal still contains some impurities. These impurities are going to be removed. Such process we are calling purification or refining. We have different methods. For purification. Different methods we have for purification. Like we have liquefaction. What is meant by liquefaction? Or what type of metals are going to be purified by this method means the metals which are having low melting point. Metals having low melting points. This is the point you have to remember. Like tin, bismuth, such metals. Tin, bismuth, lead, such metals are going to be purified by this method. But impurities having less fusible nature. Then only we are doing this. And here we have an arrangement that is sloping furnace, like this. Sloping furnace. The impure metal subjected to place here. Impure metal, that is tin, bismuth, lead. And we are heating here. We are arranging high temperature. When this is melted and it is moving on by using this slope, and here we are collecting pure metal. And less fusible impurities are left here. This is we are calling liquefaction method. The next one we have here, that is distillation. Distillation is very easy method which we learn in first PUC. Distillation nothing but heat or heating. And what is the main principle means metals having low boiling point means having volatile nature, such as zinc, cadmium, mercury. Metals are going to be purified by this method. Volatile nothing but they are moving in vapor state. When we are heating, this low boiling point metals are going to be converted into vapors. These vapors are going to be condensed and we are collecting in solid form, and impurities are left out. That impurities are non-volatile. Remember that. Impurities are non-volatile. Metal is volatile, impurities are non-volatile. Next we have an important method, that is zone refining. Zone refining. Zone refining is a purification method which, depending on differences in solubilities of metal and impurities. Metal and impurity. This is very important statement we have to do. Difference in solubilities of metal and impurities. Metal in solid form and impurities are in molten form. Molten form. And what type of metals are going to be purified in this method means, we know some semiconductors. Semiconductors like silicon, germanium, gallium, boron and indium. These are semiconductors we have. These metals are purified by zone refining. And in this method we are getting highly purified purified metals. Highly purified metals we are getting by this method. What we are doing here means, here we have an arrangement for heating impure metal. That is why we have here arrangement, and inside we are taking impure metal. This is impure metal or impure metal rod which we are going to be purified. And this is arranged between heating coils. Coils we have, that is conduction coils we are calling. Conduction coils for heating, and they are movable. We can move these coils this side and that side, both left to right. Then when we are subjected to heat, the metal is going to be absorb heat energy, start to melt. When it is melting, the impure metal is going to start to melt. And here I given impurities are in molten state. That impurities are going to be moved. For example, here I am heating means, here the metal is going to be heated means, this particular area is going to be melted and impurities are moving to here. And this conduction coil we are moving here, then here subjected to cooled, and then here we are heating, impurities are moving to here, and the conduction coil are moving to here, and again impurities are moving to here, and we can remove from this end, or we can move induction coil to this side and impurities can be moved. And at a particular zone, this is molten zone, impurities are we are removing. That's why we are calling zone refining like semiconductors. And another method we have, that is polling. That is another method we have, polling. Why this method is called as polling means, here we are using green poles, that is green wood poles. That's why we are naming as polling method. What the principle here means, impure metal impure metal contains impure metal should contains impurities of of its own oxides. That's the specialization here, of its own oxides. For example, what type of metals we are purifying means copper, tin. For you go for, if copper contains copper oxide impurities or tin contains tin oxide impurities, this is we are calling ruby copper. This is we are calling cassiterite, and this is we are calling ruby copper. See here, copper metal having impurities of its own oxides. Tin metal having its impurities of its own tin oxide. And this is method we have by using green poles. And what happened here in this method means, this green wooden pole we are using this is we are using as heating, and green wooden poles we are using for stirring. When we are using this green poles for stirring purpose, this green pole releasing hydrocarbons such as methane. This methane hydrocarbon used here to oxidize the impurities. What is the use of green poles? When we are stirring with the green poles itself release hydrocarbons like methane. This methane oxidize the impurities to its oxide form. Then we are removing impurities and pure metal we are getting. But by this method, low grade metals we are getting. This is polling process. And another important method we have, that is cupellation method. By cupellation method, we can purify the metals like generally silver, that is noble metals. What is the important principle included here means, metal having, that is impure metal having easily oxidized impurities. When crude metal having easily oxidized impurities, then Cupellation method we are acting for purification. For example, lead impurities, lead impurities in silver crude metal, silver crude metal. And what we have here, the process means, why we are calling cupellation means, in this method, oval shaped crucibles we are using for heating, and it is lined with bone ash, calling as calcium phosphate, and this crucible made with iron, and here impure silver plus impurities lead. Impure silver nothing but lead impurities are present, and these are subjected to heat in a crucible. This oval shaped crucible we are calling cupel. That's why this method we are calling cupellation. What happened here? When we heated impure metal, that is silver, and it contains already lead in the presence of oxygen, and it gives silver oxide. And similarly, lead impurities are there here. These lead impurities are oxidized to lead oxide. Lead impurities are oxidized to lead oxide. Now, both are forming. Silver oxide is forming, lead oxide is going to form. Silver oxide is unstable, thermally unstable. Why it is thermally unstable means delta G value positive. Remember, whose delta G value is positive, those are thermally unstable. Whereas lead oxide we have, this is thermally stable. And how it is thermally stable means delta G value is negative. Delta G value negative means thermally stable. Delta G value positive means thermally unstable. So one stable oxides are going to be formed in this process. But how can we do means, and it is unstable, that's why decomposed to silver and oxygen. And then we are taking this silver. Means it is a decomposed to silver and oxygen, but it is not decomposed, it is in the form of lead oxide only. So we are having the mixture of silver and lead oxide. And how can we separate means, and these two are subjected to treat with acid. Lead oxide is reacted with acid and it will be removed. But silver can't react with acid because it is low reactive metal. It can't affected by acid. So if silver is silver form only, lead oxide affected by acid, it will be removed as the impurity. And this is we are calling cupellation method. And few more purification methods we will discuss in next class. Thank you.